children, and welcome back to your chemistry class. So we continue today with the electrolysis of acid related water or the acidified water using platinum electrodes. So what is your electrolyte that we are going to talk over here? It is your acidified water. Now what is your acidified water? Acidified water means water plus 2 drops of dilute concentrated sulfuric acid. Okay, this dilute sulfuric acid, it is preferred because it is non-volatile, while dilute nitric acid or hydrochloric acid, they are volatile acids. And why are they added to water? Because water is a stable compound, right? It does not have free mobile ions, so pure water does not allow electricity to pass through. So when we add these drops of sulfuric acid to the water, the ions are formed and hence it will now allow electricity to pass through. Now we are using platinum electrodes. So platinum electrodes, they are inert, right, and they are connected by copper wires to the two terminals of the battery. Is this point clear to all of you? Ionization of this acidified water. Acidified water, it will be H2O on heating gives H ion plus OH minus. Okay, but sulfuric acid was also added to it. So what is this going to give? This is going to give 2H plus plus SO4 2 minus. Now what are the ions present over here? Let's see. Ions present, they are your H ion. Okay, H ion is there, OH minus is there, and sulfate ions are there, right? Now let's see what happens at cathode and at anode, right? At cathode, what ions are going to move? Cathode is a negative electrode, so positive ions are going to move over here. Anode is a positive electrode, so negative ions are going to move towards anode. Now since hydrogen ion is the only ion present over here, it is the only positively charged ion which has migrated towards cathode, and since cathode is a reservoir of electrons, therefore hydrogen gains over here electron and it becomes neutral hydrogen atom over here. So it will accept one electron and it will become a neutral hydrogen atom. Now this hydrogen atom, number of hydrogen atoms, they combine to release hydrogen gas. So this hydrogen gas is released at which electrode? At cathode. Is that clear? Now let us see what happens at anode. Anode, we have two ions, that is the hydroxide ion and the sulfate ions. Okay, they both have migrated towards anode. But over here, who is going to get the preference? The one which is found lower in the EC series. So who is lower in the EC series? Hydroxyl ion. So over here, this is going to lose one electron, and what is it going to form? OH, right? Number of OHs are going to combine to form H2O plus nascent oxygen. Now again this nascent oxygen, number of nascent oxygen combine and they form oxygen. So this oxygen gas is released where? At anode. I hope this is very clear. Now what happens to this sulfate ion? This sulfate ion, it migrates to anode, right? And what has happened to H ion? That has also been discharged at cathode. Therefore the concentration of the sulfuric acid will now decrease where? At cathode. Okay. Now talking about anode, the discharge of OH group, it disturbs the ionic equilibrium of the water, and to maintain it, the water ionizes further. Thus the excess of your H ions produced and the sulfate ions that are present in the increases the concentration of sulfuric acid at anode. Okay, so I mentioned it over here. Now since sulfate ions they migrate to the anode, isn't it? Sulfate ions, they migrate to anode, and hydrogen ions have been discharged. Therefore, the concentration of sulfuric acid will decrease where? At cathode. Okay, the concentration of sulfuric acid will decrease at cathode, but it is going to increase at anode. Why? Because this is one point that you should remember. The discharge of the hydroxide ion or the hydroxyl ion, it disturbs the ionic equilibrium, okay, of water, and thus to maintain it, more water ionizes, right? More water ionizes. So over here what happens? When more water ionizes, more of hydroxide ions and now more of hydrogen ions are formed. Thus the excess of hydrogen ions produced and the sulfate ions present, they increase the concentration of sulfuric acid at anode. Clear? Is this point clear to all of you? Over here at cathode, the concentration of sulfuric acid has decreased, but over here the sulfate ions are present and this increases the concentration of sulfuric acid at anode. Thus there is decrease in acidity at cathode and increase in acidity at anode. There is decrease, let me write down over here, there is decrease in acidity over here and there is increase in acidity over here. Is this point clear? Thus at the end what can we say? That electrolysis of water gives 2 volumes of hydrogen and 1 volume of oxygen. This is what is collected at the end. I hope this is electrolysis of acidified water is clear now. Now let us talk about electrolysis of copper sulfate. Okay, so electrolysis of copper sulfate using platinum electrodes, and to the other side we are going to study electrolysis of copper sulfate, okay, using copper electrodes. So difference you will easily understand. Let us begin with electrolysis of copper sulfate using platinum electrodes. So what is the electrolyte over here? The electrolyte will be your saturated copper sulfate, right? And it is always prepared in the distilled water with small amount of concentrated sulfuric acid. Why is concentrated sulfuric acid over here used? To increase the electrical conductivity of the electrolyte. Clear? Now let us see CuSO4 on dissociation gives Cu2 plus plus SO4 2 minus, right? And because it is prepared in water, so it is going to give H plus OH minus. Now, what are the particles present in the electrolyte? Copper, hydrogen, sulfate and hydroxylide. Look at the reactions at cathode and at anode. So what ions are going to move at cathode? Positive ions, that is Cu2 plus and H plus will go. Which ions are going to move towards anode? They will be SO4 2 minus and OH minus. Now over here, let's see between these two copper ions and hydrogen ions. Who is going to get the preference? Definitely copper, because copper is below hydrogen in the activity series, right? So Cu2 plus, it is going to accept 2 electrons and it is going to become neutral. Now before that, I would also like to tell you, when the electrolyte was made, the saturated copper sulfate, the solution was of blue color. Okay. Initially, the solution or the electrolyte was of the blue color. This is very important to be remembered. So over here now, back to cathode. What happened? That copper, it accepted 2 electrons and it has become neutral, right? And what do you observe over here? That at cathode, the reddish deposit is seen. Observation will be what? Observation, reddish deposit on where? On cathode. Clear? Then you can also say that the size of the cathode thickens. Size of cathode becomes thick, right? These two observations can be seen at cathode. Now let's look at anode. What happens at anode? Sulfate ions and hydroxyl ions are migrated to the anode. So over here, who is going to get the preference? OH minus is going to get the preference, because this is lower in the electrochemical series as compared to your sulfate. So here OH minus is going to lose 1 electron and it is going to form OH. Number of OHs will combine to form what? Water and nascent oxygen. Nascent oxygen combines and gives out oxygen gas. Clear? So what is this? This is the gas that is released where? At anode, which is colorless and odorless. Followed? This much part is clear. Now the question is, what do you observe at cathode? What do you observe at cathode? Reddish deposit was seen on the cathode and the size of the cathode had become thick. What do you observe at anode? Some colorless gas has been released. First point, colorless, odorless gas is evolved, right? Now what do you observe at the end of the whole electrolysis? At the end, we observe that the blue color, which was initially of copper sulfate, right, has faded out. So what do we write down over here? That the blue color fades and the solution becomes colorless. Why does the solution become colorless? Because all the copper has been deposited at cathode and there is no copper ions left in the electrolyte. Therefore, it has become faded. I hope this is very clear to all of you, right? So what did we discuss over here? That the saturated copper sulfate was blue in color, which on dissociation gave copper ion and sulfate ion, and water gave hydrogen and hydroxyl ion. So at cathode, copper ion and hydrogen ion moves. The copper gets a preference and therefore it accepts electron to form neutral atom of copper. What do we observe at cathode? We observe reddish brown deposit. You can also say pink deposit. Pink color is also correct for copper. Then the size of the cathode also becomes thick. Now at anode, sulfate ions and hydroxyl ions are there. So over here hydroxide, they are going to lose electron and they are going to give out colorless, odorless gas that is observed at anode. So overall, what do you observe at the end? At the end we find that the blue color fades and the solution turns colorless. Clear? I hope this is very clear to all of you. We now going to talk about electrolysis of copper sulfate using copper electrodes. Okay, so over here once again the electrolyte that you are going to use, the electrolyte that we are using is your aqueous copper sulfate, right? So the electrode, what are you using? Let's talk about, because here the electrode was inert, isn't it? But here it is an active electrode. This is your active electrode. So what are the electrodes that we are going to talk over here now? We are talking about cathode, which is made up of copper, right? And we are also talking about anode, which is made up of copper. Both of them are made up of copper, right? So I can draw a small figure over here to show you also. We take a vessel, right, in which there is a saturated solution of what? This is a saturated solution of copper sulfate, and it has two electrodes over present here which are connected to the battery. Okay, this is connected to the positive end, this is connected to the negative end. So the one which is connected to the positive end, what is that called as? This is your anode, and this anode is what? Your copper. And this which is connected to the negative end, this is your cathode, and presently cathode is also your copper that we are using over here. Clear? Now let us see the reactions that take place at cathode along with the observations. And here we are going to talk about anode. So on dissociation, let's see, copper sulfate on dissociation gives us copper ion plus sulfate ions, right? And water, it is going to give us H ion plus OH minus. So now cathode, what ions are going to move towards cathode? Copper ion plus hydrogen ion. What ions are going to move over here? Sulfate ions and hydroxyl ions. So who is going to get the preference here, copper or hydrogen? Copper ions are going to get the preference over here. So they accept 2 electrons and they become a neutral atom. So what do you observe at cathode? So once again, your observation over here, first observation at cathode, that pinkish deposit, or you can say reddish brown deposit can be seen over here. This can be a reddish brown deposit also. This can be pink deposit, or here you just write down reddish brown. It is not exactly reddish, it should be reddish brown deposit. And the second observation is that the size of cathode increases or becomes thick, right? These are the observations of your cathode. Now let us see what happens at anode. Anode, what is there? Sulfate ions are there and hydroxide ions are there. But do remember, anode is made up of copper. So over here preference will be given to anode instead of these ions, right? So preference is given to the electrode, to the active electrode, and therefore anode, which is made up of copper, it is a metal, it loses 2 electrons, and what does it form? it forms copper ions. Okay, so where do these copper ions go? They go into the electrolyte, into the solution. So what is happening over here? Your observation that the anode becomes thin. Okay, what happens over here? The anode has become thin. And what do you observe at the end? At the end, what do we observe over here? The blue color had faded. Why? Because all the copper ions which were present in the electrolyte, they became neutral at cathode. Whereas here what is happening? The copper ions, they are depositing at cathode, but anode at the same time is releasing copper ions into the electrolyte. This anode is continuously releasing copper ions into the electrolyte, right? Therefore, there is abundance of copper ion in the electrolyte, and hence over here the color will not fade. Therefore, at the end, what do we observe? The blue color of the electrolyte remains the same. Okay, the blue color remains the same over here, whereas here it had disappeared or it had become faded. So now what is the work of these two ions then? Sulfate ions and hydroxyl ions, which had moved towards anode to get deposited over there. So since they have no work over here, so they are termed as spectator ions. Who are spectators? Who just observe, right? So here they are just observing, they are not able to do anything. Who is playing active role over here? The electrode is playing the active role over here. They are just the spectators, and therefore we say that spectator ions are your sulfate ions, your hydroxide ions, and even your hydrogen ions. These are all your spectator ions, right? So let us understand this electrolysis of copper sulfate using copper electrodes also. That we take aqueous solution in which we had added small amount of sulfuric acid to it. What was the work of sulfuric acid over here? It enhances the rate of reaction. Then what type of electrodes are we using? We are using active electrodes, both cathode and anode, made up of copper, right? So what are the ions that are given out in the electrolyte? Copper ions, sulfate ions, hydroxide and hydroxyl ions, right? So let's see at cathode what happens. Copper ions and hydrogen ions, they migrate, and copper accepts electron and becomes neutral. So what do we observe at cathode? That some pinkish deposit or reddish brown deposit was seen on cathode, or we can also say the size of the cathode had increased or becomes thick. At anodes, those sulfate and hydroxyl ions are there, but they just act as spectator ions. Why so? Because over here the active electrode is given the preference. So active electrode is made up of copper. It will lose electron and give out copper ions. So there will be abundance of copper ions present in the electrolyte, and hence what we will say, that at the end the blue color of the electrolyte remains the same. It does not get faded, right? So this was the difference between electrolysis of copper sulfate using an inert electrode and using a active electrode. We stop over here. Try to understand this. It's very important. Every year it is there in your ICSE paper. So understand this well. Next time I shall come back with the applications of electrolysis. Thank you.